Hi, Team Learn at Home. Welcome to a Titanic Math Thursday. Today, you're going to experience some truly titanic numbers through the power of scientific notation. And let me show you where to find the work for today. So it's got right in here 1.4 working with scientific notation. You will find that in your D2L. I'm not posting links anymore. It takes me too much time. You go ahead and you find it yourself. Now, let's take a look at some of the things that we can get started with to help you out. I'm just going to review this situation here, 180 over 60. What's that? Well, I think that is, if you recall, so you'll recall that 2 nights ago I had a big pizza feast where I was eating pizza for 180 minutes. And I asked how many hours was I eating pizza, and people were very quickly able to tell me that 180 over 60 equals 3. All right, people just knew. All right, that's great, but we want to take those things that we're really confident with, and be able to understand why they work. Now, you might say, well, Mr. Jennings, you've been teaching us to do factor trees, where we would take 180 and we would divide it by 2 and get 90, divide that by 2 and get 45. And then we'd say that's divisible by 3 and we'd get 15, and then we'd 3 and we get 5. And that's a lot of work to find out that 180 is 2 times 2 times 3 times 3 times 5. And I agree, that's more work than you need to do here. Factor trees are just one tool. This is the main thing, to be able to see that that's 3 times 60 on top, 3 multiplied by 60 divided by 60, and that the 60s can cancel. I like to organize these things so I can cancel nice chunks. And you want to find these chunks and then cancel them away to simplify your fractions. So when we encounter fractions that have scientific notation in them, we can use the properties of scientific notation to make this very convenient. 8.0 times 10 to the 5 divided by 4.0 times 10 to the 3. This is already factored for us partially, okay? So let's write this just in a different way. This would be like saying 8 is 8.0, that's an integer, multiplied by 10 5 times. 10 times 10 times 10 times 10 times 10, okay? And then it's divided by 4 times 10 times 10 times 10. Okay, so this is 10 to the 3. 10 multiplied by itself 3 times. This is 10 to the 5. And then we look for factors that we can cancel. This 10 cancels that 10, that 10 cancels that 10, that 10 cancels that 10. And so yesterday, some of you noticed that, and then 8 divided by 4, that's 2. Okay, I could write this as 4 times 2 or 2 times 2 times 2 and then cancel, or I can just know that 8 divided by 4 is 2. So this would be 2 multiplied by, circle what's left, 10 times 10. 2 times 10 times 10, which is equal to 200. 2 times 100, 2 times 10 to the 2, blah, blah, blah. Okay, there, circle final answer. Some of you yesterday noticed that our result here, 2 times 10 squared, 10 multiplied by itself twice, we could use these exponents and just subtract those exponents to get that 2. And that's a profound realization that's going to save you time. And so let's use that today with the various work that you have to tackle. And let's try this one here. Well, notice here, we don't have integers there. 2.1 is not an integer. It's a rational number. 3.5 is also a rational number. But because we're multiplying those by tens, they become integers again. The decimals go away. So let's take a look. We'll expand this out a little bit. 2.1 times 10 times 10. I don't feel like writing out all the rest of the tens. I know this is 10 multiplied by itself 7 times. So this is 10, that's 1 times 10, 6 more. That would be 10 to the 7, okay? All divided by 3.5 times 10 times, well, I'll just use what's left, 10 to the 6. Sorry, 10 to the 5. So I'm going to borrow one of those 5s from each one of these, and then I can multiply these in. 2.1 times 10, well, that's 21. Multiplied by 10 to the 6. So I'm going to actually do that multiplication and that multiplication. 3.5 times 10, 35 times 10 to the 5. Okay, I haven't changed this. The equal signs means it's the same. I've just written it in a new way that's more convenient to my purposes. Now, 21 divided by 35. How can we do that? Now we might use our factor trees. So we might say 21 is divisible by 3 and 7. Cool, those are prime. And then 35 is divisible by 5. Oh, and then what? 7. Oh, I see something that's going to cancel. So what I do next is I'm going to rewrite 21 over 35 as 3 times 7 times 10 to the 6 over 5 times 7 times 10 to the 5. Okay, and now I can see I can cancel this 7, cancel that 5, and I'm left with 3 over 5 multiplied by 10 to the 6 over 10 to the 5. And we just saw that we can subtract the exponents. So 6 minus 5 would be 1. So let's rewrite that. This is 3 over 5 times 10 to the 1. There's only one 10 left over here. The 5 tens under here cancel those 10 tens. Now this is not scientific notation yet, so I might evaluate that on a calculator. 3 divided by 5. Okay, and so 3 divided by 5 is 0.6. So you can use your calculator. I happen to have a calculator implanted in my brain from years of math practice. So you'll develop yours by using your brain. So 0.6 times 10 to the 1. This is a set of instructions, says move the decimal place 1. So this is equal to 6. Circle it, final answer. Isn't that surprising? That a crazy looking number like this is just equal to 6. What mad genius created those questions? Not this one. I'm not a genius. So anyway, that's how you can use division laws to simplify those things. But we can also use this when we're multiplying scientific notation numbers. For example, if I have 3.0 times 10 to the 3, and then I'm going to multiply this scientific notation number by another one, we'll say 2.0 times 10 to the 2. Okay. Now, multiplication, this is a chain of multiplication. There's 4 elements being multiplied by each other. 3 times 2 times 10 to the 3 times 10 to the 2, and it's all being multiplied. It doesn't matter what order I multiply these things in, because multiplication doesn't care about order. So I could write this as 3 times 2, and that's easy to do. That's 6, times 10 to the 3 times 10 to the 2. I'll group these. All right, let's just flip over our color because we're going to start changing things now. 3 times 2, this is still equal to 6 times 10 3 times, times 10 twice. 10 times itself 3 times is 1,000. 10 times itself twice is 100. So 100 times 1,000 is 100,000. Or 1, 2, 3, 4, 5 zeros. That's what happens when we multiply by 10. We grow zeros. Okay, so this is equal to 6 times, let's write this as a power of 10. 1, 2, 3, 4, 5 times I multiply by 10. So this is 6 times 10 to the 5. Do you see the connection between these numbers and this number? Yeah, that's right, folks. When you're multiplying powers with the same base, you can add the exponents. So we can use that to simplify our scientific notation questions very quickly. All right. So I hope that helps you get started on your practice today. And I wish you all the best. Any questions, hit me up by email. And otherwise, I will hope to see you in class Friday or Tuesday. Bye for now, everyone.